How is heat, Q, part of the first law of thermodynamics? Have you ever wondered how energy moves around in our world? The first law of thermodynamics gives us a clear picture of this energy dance. It's all about energy conservation, which means energy cannot just appear or disappear. Instead, it changes form or moves from one place to another. So, how does heat fit into this? The first law states that the total energy of a system can change only through energy transferred as heat or work. Heat, often represented by the letter Q, is one of the main ways energy crosses the boundary of a system. The other way is through work, which we will touch on shortly. Let's break this down with a simple equation. The change in internal energy, represented as delta U, equals the heat added to the system plus the work done on the system. This means that if you add heat to a system, you increase its internal energy. If you do work on the system, that also increases internal energy. Heat is energy that moves because of a temperature difference. It's important to remember that heat is energy in transit. It doesn't sit inside the system. When heat flows into the system, Q is positive and the internal energy goes up. When heat flows out, Q is negative and the internal energy decreases. Now let's talk about work. Work happens when forces act over distances, like when a gas expands and pushes against a piston. Both heat and work are forms of energy transfer. However, only changes in internal energy are stored within the system. Here's a practical example. If you heat a gas in a closed container, the internal energy increases because of heat transfer. If that gas expands and pushes a piston, it does work on the surroundings. This can lower its internal energy if no heat is added. In engines and refrigerators, managing heat and work is crucial for efficient energy changes. By focusing on heat as a form of energy transfer, the first law connects everyday experiences like heating and cooling to a fundamental principle. Energy is conserved. It only changes form or location through heat and work. Understanding how heat is part of the first law of thermodynamics helps us grasp the basics of energy conservation in our daily lives. Whether it's cooking, driving, or just enjoying a warm cup of coffee, the principles of thermodynamics are at play all around us.